The vectors, when they give us two vectors, like two forces, and then it says find the magnitude of the resultant force. So you got two vectors, it'll look like this of grams, kilograms, whatever, and then you got the theta between the two vectors talking about the resultant force. This is where we're going to draw a parallelogram. We're going to find the resultant vector. We're going to use the supplement of that angle. We're probably not going to end up using the 140 degrees right here. I'm going to draw a picture. Let's just kind of show you how to do one, possibly two of these for sure, and then we'll be good there. But it gives us, we have two vectors. One force is 19 grams, another force is 30 grams. And then the angle between those two vectors is 140 degrees. Now, when it wants the resultant vector, it wants us to add up these two vectors. One way to add up these two vectors is use the parallelogram law. So I'm going to draw this parallel to that, and I'm going to make this one parallel to this one. So this is like another 19 over here. This is like another 30 over here. And then remember the resultant vector, they want us to find this vector right there, the length of that red vector, okay? And then remember the supplement, these two consecutive angles of a parallelogram are supplementary, which means they add up to 180 degrees. So if I go 180 minus 140, that gives me 40 degrees right here. And now what I want you to look at is this triangle right here. So I have this triangle, right? We know this is 30, this is 19, and this is 40 degrees. And you're supposed to calculate this one right here. So I'm going to call that X, and then we're just going to now solve a triangle to figure it out. Now, anytime you know these two sides with that opposite angle, this is straight up your law of cosines right here. So I'm going to go X squared equals, we're going to go 19 squared plus 30 squared minus 2 times the 19 times the 30 times the cosine of that opposite angle. And then when you do this, you're going to do a giant square root first, and you're just going to enter that all into the calculator just like that. So let's do that real quick together. So I'm going to hit my square root button first, and then I'm going to go 19 squared plus 30 squared minus 2 times 19 times 30, or you could put them in parentheses there, and I'm going to do the cosine of that 40 degrees, and then I'm going to hit enter, and that's going to give us 19.69. And that's it. You're done right there. Technically, it'll be grams, like it's the actual resultant force. But make sure you're using the 40 degrees, not the 140 degrees, okay? So just be careful on that. Let's just do one more just for fun, and then we'll talk through a couple others there. If I jump down and do letter D gives us another two vectors there, and it says the angle between the two vectors is 73 degrees. So if I have one vector is 15, the other vector is 22. It doesn't matter if you switch those around at all, and then the angle between is going to be 73 degrees. So that's not drawn to scale. Okay, I could have drawn a little bit more acute than that. But then if I want to find the resultant vector, I'm going to draw another parallelogram, and I want my vector to be that one right there. And so I have to go 180 minus 73, that's going to give us 107 degrees for that supplementary angle. And I know if that's 22, this is going to be 22, and I'm going to call that X right there. And then so I'm just looking at that little triangle. So I'm going to use my law of cosines again. I'm going to go X squared equals the 15 squared plus the 22 squared minus 2 times the 15 times the 22 times the cosine of that opposite angle, which is 107 degrees. And then you're going to do the square root of all of that into the calculator like I just showed you on letter A. And if you do that properly, you should get 30.03, and then the units on that will be kilograms right there. All right, so there's all four. See if I can zoom out a little bit. There's all four of my answers on that with all of my work. So you can get what you need from that. But every single one, I'm drawing the parallelogram using the supplementary angle. So technically, if you did enough of those, you don't really need to draw the picture. As long as you use that supplementary angle, you're going to be fine. But you know when to do that is when they give us a couple of vectors with the pounds, grams, whatever. It's two forces, and you're finding the magnitude of the resultant force. That's that technique right there.